All right, so we have two more videos to end it out, and they're really over the same topic. One is going to be more numbers based, and one's going to be a little bit more conceptually based. We're going to talk about this concept called elasticity of demand. So to sort of introduce this concept, we're going to return to demand functions real quick. So here's an example of a demand function. P is equal to 150 minus 0.01x. Again, this is a demand function. Let's write this in a different color. And it shows the relationship between price and demand. So specifically, right, if I raise my price, the demand goes down. If I want to sell more units, if I want X to get bigger, I'm going to have to lower my price. If I want to sell more things, I can't charge as much. Okay? So what we're often going to do, and again, we've talked about these functions kind of before, and the fact that, okay, how do we interpret this function? If I don't sell anything, if X is 0, price is 150. If I charge $150 for this product, nobody's going to buy anything, which is bad. But for every additional unit I want to sell, as X gets bigger and bigger, I'm going to have to lower the price by a cent. So I could sell a lot of things if I lower the price by a lot of cents. All right, and that's the relationship there. Okay, so sometimes, especially in economics, we call X Q. Q is the quantity of items that we're going to sell. It doesn't matter what we call it, what letters we use, but a lot of times we'll call them Q in this case. And so we can rephrase this demand function as Q. If I solve for X and rename it as Q, I believe is going to be 15,000 minus 100p. And this is the same information. This is the same information. The difference is it relates it in a different way. Okay. So now, right, if I don't charge anything, if P is 0, we can get rid of 15,000 of these. And, oh, where'd my P go? And then for every increase in price of $1, we're going to sell 100 fewer. Every increase of price in $1, we sell 100 fewer. Just like if we want 100 more, the price goes down by $1. So again, it's just the same, two sides of the same coin. All right. So these are demand functions. And a question that we can often ask ourselves, there's two questions that can arise here, is how does price affect demand? And this is a relatively easy question to answer. In almost every situation, not technically every situation, but almost every situation, an increase of price will decrease demand. There's an inverse relationship. The more I charge, the fewer people are going to buy something. The less I charge, generally the more people are going to buy that product. Okay? So this is a usually easy question to answer. A harder question to answer is how does P affect revenue? Okay? And we've answered this question a little bit. It was a little bit more complicated. Remember, we said that revenue is equal to P times X. The revenue is just how many things are we selling times what are the price that we're selling them at. Okay, and we set up this revenue function. We found the derivative to find the maximum point for our revenue, and we did this. There's another concept that we can use to talk about this. All right. Sometimes increasing our price will increase our revenue. That'll be when the demand is inelastic, we'll say. Sometimes increasing our price will decreasing our revenue. And that is going to be something called elastic demand. Okay? So the elasticity of demand we're going to do on the next page. Elasticity of demand. Often we'll call E of P. Helps answer this. So it's kind of funny that it it's funny to me, maybe it's not funny at all, but the elasticity of demand is actually a function of the price, not actually the demand. But anyway, here we go. So E of P is going to be the relative rate of change of our demand, Q, divided by the relative rate of change of price. We want to know, so a lot of times when we deal with ratios like this, when we deal with fractions like this, we really care about, is this fraction bigger than 1? Because if this fraction is bigger than 1, the top has to be bigger than the bottom. If it's smaller than 1, the bottom's bigger. So the question is, to kind of think about how this affects our revenue, all we have to do is look at these, the frequency, the relative amount of each one of them. And what's interesting right here is this is always a negative number, because the relative rate of change of the quantity is, right, it's always a negative slope. Increasing price is always decreasing quantity. So this whole thing is negative. So what we do, we don't like negatives, especially economists don't like negatives. They put a negative sign in front of the whole thing. Negative, this negative sign doesn't mean the whole thing is negative. Negative means opposite. So if this fraction's negative and I want it to be positive, we just make a negative sign when we talk about elasticity of demand. It's a lot easier to talk about positive numbers than it is to talk about negative numbers. Okay. And then if you do some steps, and I'm not going to show them here, but we know how to find the relative rate of change. That's the derivative divided by the function. So if we did this and did some simplifying, we're going to get negative P times F prime of P over F of P. Or in other words, elasticity of demand is just P times the logarithmic derivative. So this is a function. I will give this equation to you. I'm not going to have you memorize it for the final or for the quiz this week. That's the elasticity of demand. We can say some of these things. If it's bigger than 1, if it's smaller than 1. Because if it's bigger than 1, that means the top is bigger. If it's smaller than 1, that means the bottom is bigger. Okay? So what we say is that if E of P is greater than 1, that our demand is elastic at that price. If E of P is less than 1, then our demand is inelastic at that price. So it really depends on what price we're charging, whether demand is going to be elastic or inelastic. Depends on the price. Okay. So if it's elastic, that means that the number that we can sell is going to change a lot more than the price. And this is, well, we'll talk about what that means. And if it's inelastic, that means the bottom is bigger. Or the price is going to change a lot more than the actual quantity we sell. So if we can change the price by a lot and it doesn't change the demand very much, we want to increase that price if we want to maximize profits, right? If we rack up the price and people are still buying it, that's going to be beneficial for our revenue generation, at least in the short term. Okay. So we'll talk more about what this means in the next video, but let's actually do an example. We did some concepts. We built some stuff up. Now let's do an example. Ejemplo 3. Find E of P, find our elasticity of demand, and determine if demand is elastic or inelastic. At the given price. So this is just kind of finding derivatives using a formula, plugging things in. And then we'll talk more conceptually and application focused in the next video. Our demand function is Q is equal to 600 times e to the negative 0.2p. And I specifically want to know a price at 10. So a lot of times we dealt with linear demand functions in this class. Here's a nonlinear demand function. This demand function is exponential. Okay. So initially, right, kind of what this function would look like if you knew, you've done as much math as I have, you probably will know. Initially, an increase in price has a very large increase on quantity sold. But later on, right, it gets kind of flat where the relationship between price and quantity is different. Increasing price doesn't change quantity very much at this point because basically nobody's buying it in the first place. It's so small eventually that it doesn't do much because, well, there's not. If only one person's buying your product and you increase your price, yeah, it's not going to change by very much. But it's still not a good thing. Anyway, we're curious about what happens when we're charging $10 or whatever our units might be. So remember, E of P is equal to negative P times F prime of P over F of P. And I don't think I explicitly said it, but this is our function of P. That is F of P right there. It's the demand solved for Q, solved for our quantity. So sometimes these can get a little messy. All right. So good luck. Be careful. Do your steps right. You have negative P times the derivative. What's the derivative? The derivative of an exponential function is itself. Chain rule, chain rule, chain rule. It's itself times the derivative of the inside, the derivative of that exponent, which is negative 0.2. We divide that by the original function, 600 e to the negative 0.2 times P. That decimal place got really stretchy. It's connecting to the top of the tube, but don't worry. You don't have to simplify here because we really only want to know the value when it's 10, but sometimes simplifying will make things easier. The function itself is on the top and the bottom. That can cancel. And we have a negative times another negative. The elasticity of this demand function is actually pretty straightforward. It's just zero. What's left is just 0.2 times P. The elasticity of demand when P is equal to 10, right? So elasticity when P is equal to 10 is 0.2 times 10 is 2. And this number, notably, this number is bigger than 1. So this is elastic. And if you're ever unsure of remembering which case is elastic, which case is inelastic, it's more elastic. The elasticity is higher here, right? E is elasticity. The bigger the elasticity, the more elastic it is. Okay? So we're going to say, yes, this is elastic, which will tie in the next video to say that we're charging too much here. Okay? If we want to maximize our revenue, this is elastic. We need to decrease our price. We'll also kind of show and talk about that we want the elasticity to be 1 to maximize our revenue. We should actually be charging $5 here. But anyway, that's the future. We're just focusing on the calculations in this video. We'll talk more about what it means in the next one. All right. One more comment here before I get too excited. The elasticity is 2 divided by 1. Remember what elasticity was. This means, right, our elasticity was 2, which is 2 over 1. So the relative rate of change of the quantity is changing faster than the price. A small change in the price is having a bigger change in how many we can sell. All right. Let's do another one. Part B. Q is going to be 700 divided by P plus 5. We're curious about when the price is 15. So again, we just need to use the definition, calculate a bunch of stuff, and see, is our answer bigger than 1 or smaller than 1? So we look at Q prime. And again, maybe go off to the side and say, okay, we could rewrite this function. It might be a good idea to rewrite this function this way. because the derivative, we can just use the power rule now. Anyway, our elasticity is going to be negative P times F prime of P over F of P. This one's going to be a little ugly, okay? So strap yourselves in and be very careful. We're going to have some big complex fractions. So the derivative of this function is a power rule. Bring down the negative. Becomes negative 700. Inside stays the same. Subtract an exponent. Multiply by the derivative of the inside. Right? The derivative of P plus 5 is 1, which is nice. All right, and we divide by the original function. I'll write that as 700 times P plus 5 to the negative 1. I'm writing negative exponents here because I really don't want to deal with complex fractions. I really don't want to have fractions inside of fractions. And we do, but it looks a little nicer here. And we can cancel, just like before. So again, that normal fraction is always going to be negative, so we should always have cancellation here with those negatives, and we should always get a positive value here. And then the 700s are going to cancel, no problem. And then one of these is going to cancel with one of those. All right, so we're just left with a negative 1 on this exponent. We can do a little simplifying. And what's left over? We have a P that's now positive. We have a P plus 5 to the negative 1. I think that's everything that's left over. This is the elasticity of demand function. And specifically, we're curious about what's this elasticity when P is 15. So we'll plug in 15 over here and say, okay, that's 15 divided by 15 plus 5. Remember, negative 1 exponent just means that thing is in the denominator, which is going to be 15 over 20, which is 3/4. And 3/4 is less than $1. All right. This number is less than 1. So again, this is our elasticity. It is not very elastic. It is less than 1. More than 1 means, oh yeah, elastic. Less than 1, not very elastic. We even might say inelastic. All right. Which we'll eventually say means we're not charging enough. We can increase our price without changing the demand very much at this point. And if we can increase our price and that doesn't affect the demand very much, let's increase our price, make more revenue. So, yep, that's elasticity of demand. Nice long video here. It's a kind of a cool topic, and I wanted to make sure I gave you guys enough examples. If you have more questions about this, it's really fun to talk about, but I'm trying not to go into too much theory and stuff in these videos, but feel free to reach out to me on Slack or message me on Canvas. I'd be more than willing to talk about it. All right, good luck.